Hey guys, welcome back to Awesome Everyday. Where today we are going to be doing something a little bit on the physics side or the electronic side. So today we're going to discuss about wireless energy. But remember, this is not free energy. This is just wireless energy, like how wireless chargers work. So you're gonna need some coils, a transistor, an NPN, and a battery, and hopefully you have a battery clip. A multimeter is just for testing. If you have an LED, that will work great. And a bunch of more wires. This is about the total of this is 5,000 turns, but I have taken a center tap and it's about 2,500. This coil, this is the main coil. So from this to the center tap, it's about 15, and from this to this it's about 20. So yeah, I did not have enough, and those were fireworks if you will them. So yeah, this is the main coil. This will emit, and we're gonna make a new coil that will receive it. And just for fun, let's see if we can step up the voltage from total of about 35 turns to 2,500. Let's see what will be the readings. And yeah, we're only using the transistor because we need an oscillation or an AC signal, which my multimeter helpfully provides. But I am not going to be using that function. This one, the square wave generator. So let's get building. Okay, so now we're gonna make the receiver coil. So yeah, this is the emitter coil. Go ahead and make it. The dimensions aren't super critical, so I just wrapped around some aluminium foil, roll, a toilet roll. I folded around that, and yeah, I don't know the dimensions. But for the receiver coil, I'm going to use this deodorant. So yeah, I'm just gonna see how many turns I can get. Hopefully it's about 20 turns. So guys, I'll be back when I've made it. Okay guys, the coil is done, and you can see this is the beginning wire and this is the end wire. I purposely left this much out because once we take the coil out, we're going to wrap it around it several times just so it keeps the coil in place. Or you can also use tape. So I'll be back when I actually remove the coil. You don't need a center tap in the receiver coil. Okay, sorry, the coil is done, and as you can see, I've actually turned them like from inside through the loop so that the coil will stay, and it's about the same size. So yeah, no, pretty good. I'm going to sand these off because this is magnet wire. It has a thin insulation on top, so you have to remove it because look, I've removed it, and as you can see, it's not showing up in camera, but it has red color over here. But when you strip it off, it becomes some dull color, as you can see. So I'm going to do the same thing with the other side. If you don't have a sandpaper or something like that, you can just simply burn the enamel off. I've also done it with this coil. As you can see, I've actually burned it in here. So yeah, I will show you the circuit diagram right now. So yeah, as you can see, this is the emitter coil. This one, it has a center tap, and these two. So this one goes to the positive of our battery, and this one goes to the base. You can also put this one to the base, but I choose this. And other one to the collector, which is represented here, and the emitter of the transistor has to go to the negative. So from my transistor, the red wire is the base, the top wire is the collector, and the bottom black one is the emitter. So my transistor number, actually I don't remember it. It's not showing up here either because I've actually sorted it, so it's kind of hard to see. I'll write it down in a second. So yeah, I just want to tell you how this works before actually making it. So this is a high frequency oscillator. What it does is when current flows from the center tap, it first goes to the base. it does not go to the collector because the base is like a switch. If it is open, or when there is no voltage through it, no voltage can go from collector to emitter. So first it will go here and a current will be induced in this direction. So it will go to the base and open the gate, and as soon as this here, as current has gone through it, there will be a current induced in this. Depending on the number of turns on these two coils, the total number of turns, suppose if this is 25 and this is 50 and you apply 9 volts here, it will be approximately 18 volts here. So it is, it's a high frequency transformer. So when it goes here and the current is induced here and here through the air core, so the air core, it opens the gate, and then the current can go from the positive through here. Usually there is a resistor at the base so that more voltage can go from this side and not this, because electricity chooses the least resistive path. But in this it does not matter. So then, because this is open and the base has usually a higher resistance, then the positive will go here and then flow from this side. And then through the collector, because the gate is open, it will go from collector to emitter and to ground, or negative in my case. And this induces a voltage in this direction. Now because all the voltage is flowing in this direction, no voltage is flowing in that direction. That means the gate is closed and the voltage can flow this side as well. So now the voltage isn't flowing this side, the cycle continues. It goes from this side again, and this side is induced, then it goes from this, and this is very fast. And I'm not sure what the frequency is, but it's extremely fast. So yeah, this is a circuit, and my receiver coil has about, this is the emitter coil with 3 points, and this is the receiver coil with 2 points. I actually sent them off. And this one actually has about 30 turns, but that one has 25,000. So we'll compare. So let's get to building. So this is the code of my transistor. It's T4205D, but I don't know what this line stands for that it's under here. It is HTUICI. So I don't know what that means, but yeah, this is the main part. D4205D. And as you can see, you'll also need a heatsink because I'm using 9 volts, so it's gonna be pretty much high volts. It can burn small transistors, so use 5 volts if you can for small transistors. And the first one, base, and the top and the middle pin is the collector in my case, and the last one is emitter, but it can be different. So I'll be back when this circuit has been built. 5 seconds later, it's built. So now, I need a switch. I'll be back with a switch. Okay, so apparently I didn't need a switch, so that was my switch. So I've connected the multimeter first to this one. As you can see, these two are, I'll just connect them. And this is my circuit, and this is the battery I'm going to be using. As you can see, I put this on 20 volts first to check the voltage of the battery, and it comes to be around, let me just connect them. Yes, it's about 5.6. It's about 6 volts, but the coil has some resistance as well. Let's check that too. So I put this to 200 ohms or 2K, and it's about 220. So because this will be generating an AC, I'll put it at 200 volts AC. For now it's 0, and let me just connect this. Okay, the circuit is now oscillating, and let me just put the coil on top. You can already see a voltage of 2.5 volts induced. As you can see, it is not connected. Okay, 3 volts. Could be better. Come on. Let me just move it. So I bet 3 volts was the best it could handle, but my transistor here eats a lot of power, so my battery is mildly warm, but as we can see, energy is being transferred. So now let's try with the smaller coil. Okay, so I've connected the coil and its resistance is about 1.2 ohms. So let's connect the battery. Okay, so the circuit is running and yeah, 0.1 volt, 0.2. It's not good. Okay, like that one, much better. Okay, 3.6 volts. Pretty nice. So let me just try using a different transistor that has, less resistance, internal resistance apparently. Because this one sucks lots of power. So it's wasting energy. Okay, so I've got a new transistor. So let's see what happens. So first this is the coil, this is the state. As I move this closer, more closer, more closer, and then finally on top. I've genuinely no idea what has happened. So 1.3 and it's in air. So when it touches the ground, 1.9. Seriously? Okay, now it's 2.6. What? That means if I do this, it produces high voltage spikes. Nice. The battery is not getting warm anymore. Let's take some paper. Mine just flew away. Like this. So it's 1.6 volts. And now it's 1.2 volts. And as you can see, it's on a paper. And let me put my hand underneath it. And then this over my coil. Something like this. And it's basically nothing. Let's remove the paper. Put this on top. And that's a voltage spike. Yep, you can see the 1614 volts. Wow. 12 volt, I saw some 12 volts. So if I put my hand over it, everything gets blocked. So yeah. What? So let me just switch it off. Turn it on. Put this on top. And our 1.6 volts AC. Let's check the DC. DC is about, it's negligible. 1 volt spike is better off in the AC. So it's 1.4 volts. Okay. Let's do some experiments. So this is your resonance circuit. So I'm wondering if this is the emitter side and this is the receiver side, and if we remove this but keep this capacitor here, which is originally not in the circuit, what will happen to the voltage? Let's see. Got my small capacitor. So the voltage is about 1.1 and okay, let me just extend it legs a bit. some more. So it's still 1.2. And if I put capacitor, oh my god, the capacitor is not setting. I'll be back. As you can see, nothing happens when you short it with the capacitor. So this is it. Hope you liked this video, and hopefully you've subscribed. So as you can see, it's pretty cool. What the heck has happened? Wait, I got an idea. Let's keep the sender coil down and the receiver coil up. As you can see, I am still getting about 1 volt approximately. Okay, it dropped to 1.4. Oh, I saw some spikes. Yep, 1 volt. Nice. 2 volts, 2.2, 1.5, 1.3, 1.1, 8. Oof. So, I'm gonna have some fun. Till then, hope you see my other videos. And go ahead, try this for yourself. It's pretty fun, it's pretty cool. So like, share, subscribe. For now, goodbye.